All right, so for the next big section of class, we're going to be talking about finding areas under curves and all the tools we need to do that. So the first thing, just like what we started out with derivatives, we can only approximate and kind of guess the right answer, and then we'll slowly build up to the point where we can find the exact right answer. And here's the basic idea. We have a lot of formulas for the area of an object, so we can find the area of a rectangle, or the area of a triangle, we have a circle. All right, for these kind of nice uniform shapes, we just use these formulas. What happens if we want to find the area of some kind of weird shape like that? All right, it's not a circle or a triangle or a square. All right, so we can't just use a formula. We want to figure out a way. How can we figure out the area of this shape that I drew? And the basic idea is we're going to use a shape that we are very comfortable with, a rectangle, and use that to approximate the area. So we're going to use these rectangles, and we're basically going to add more and more rectangles to get closer and closer to the right answer. And then using calculus, we got to take our approximation into the actual exact answer. All right, so here's a picture of what I'm talking about. Basically, in this picture, I'm trying to find this area underneath this curve, right, this kind of curved area there. All right, so in that blue box, that's the exact area we're trying to find. All right, but we can't just find the exact area of this shape using our normal methods because that kind of curve isn't one of the nice shapes. So what we do is we take all these little rectangles, all right, and these are going to be pretty close to the exact area. It's not the exact area because we're missing some bits all over the place. All right, but that'll give us a basic idea of what the area should be. And then, well, we recognize if we make the rectangles thinner, we get less missed spots. So these little missed spots along here, there's more of them, but each of them are a lot smaller. This area of all these rectangles on the bottom is going to be closer to the exact answer than the top one. So basically the idea, we went from 8 rectangles to 32 rectangles. We get closer to the answer. We can go from 32 rectangles to 100 rectangles or 1,000,000 rectangles or whatever. We'll get slowly closer and closer to the answer. And we basically use that idea of calculus. As we get closer and closer to something, we get the actual answer. All right, so this is what we're going to be talking about in this set of videos. All right, trying to make these rectangles, add them all together, and we get a basic idea for what the area should be that we're looking for. And again, right now, it's only going to be an approximation, and we'll build up to the point where we actually get the exact right answer.